Okay, I don't have the exact details worked out, but I have a pretty clear idea now how this is going to play out. Basically, the loopster directions that you are working on now are called the general loopster directions. At the end of it, we'll put some kind of note that says on the next 3 pages are 6 examples of basic loopsters. They have 4 different or just like the example we just did in detail. Here are some that your students can practice on. Note to teacher, be sure to emphasize not to fill in the circle unless you can prove it. If you are not positive, you should put the small indicator numbers. You should only fill in the large circles if you are positive that the order of the numbers, and that can be proven somehow by logic. Then we'll go to a next page where we'll say, now in this multiplication book, we're trying to master our multiplication tables. So table-specific loopsters have been made. They're very similar to regular loopsters in a lot of ways, except instead of having 4 different numbers, they still have 4 numbers, but 2 of them are the same. They are the number of the table that this loopster is specific to. So for example, one of the two two times table specific loopsters is the loopster 2213. That means in every row and every column you have 2 2s, 1 1, and 1 3. The logic, however, remains the same, and then we'll proceed to show them one. Okay, and you can start with this picture and say, again, it's got 16 circles, it's got loops, the numbers are inside, the products are inside, and blah, blah, blah. And then beginning the puzzle, start in the upper left-hand corner if you want. It is a 2. You know that it's 1 times 2, but you don't know which order they go in yet, so you're not going to fill the numbers in the circles. You're just going to put your indicator numbers. Okay, now moving to the one next to it, it's a 4, which can only be made from 2 times 2. And since the order is guaranteed, then you know that you can fill those into the circles. Okay, next you go down to the 6. You know 6 can only be made from 2 times 3. And if you look up at your 4 above in the second column here, you have 2 2s. So you know you can't have any more 2s. That's got to be the 3. That right circle's got to be 3, which means the other one's a 2. So then you get this picture. Looking in the second column, you have 2, 2, and 3. So the missing number you know is 1. And 1 times what is 3? You know the other number's got to be 3, and you end up with this picture. Moving along to the next one, you got a 2 as your product. You know that it's 1 times 2, and when you look at the bottom column, you've already used a 1 down there, so you can't have a 1 in the bottom row. It's got to be in that next row up. So that can't be a 1, so it's got to be a 2, which gives you these 2 numbers. Looking at the next one, it's a 4. You know it's got to be 2 times 2, so you know you can fill those right in. Next is 3. You know it's 1 times 3, but when you look, our third column already has a 1 in it, so the left circle can't be a 1. It's got to be the 3, which means the right circle's got to be the 1. There it is. The next one is a 6. You know it's 2 times 3. You already have a 3 in that third column, so you know that's got to be the 2. And the 3's got to be in the last, the end circle. And if you look, then that completes that column as well, which leaves our original loop at the beginning. You look at your top row, you got 2 2s and a 3, so you know you're missing the 1. And then your second row, you got a 2, a 3, and a 1, so you know you're missing a 2, and you end up with this. And somewhere in there, maybe after it, we'll say numerous examples of this exist on my YouTube channel with voiceovers that explain the logic. They can be used for teachers to understand the game, but they can also be shown to students to help them follow the logic. Once students are aware that you can only fill the number in the circle when you're sure, then the puzzles become highly solvable and dare I say, fun. And there we're done. Okay, so I'll get in touch with you later. Bye. Thanks again.